Hello everyone, happy Thursday to you all. Hope you're all doing well. Before we begin, wanted to do a birthday shout out to Natalie Eichner, whose birthday was on April 8th. Happy birthday to you. Okay, today we are going to be doing questions 38 through 44 in multiple choice. You can go ahead and cross out 42 since it was a repeat. And then we're going to do question 17 in the short answer packet. Okay, so let's go ahead and get started on question 38. Make sure you have your calculator handy because a lot of these questions can be answered using your calculator. All right, so it says here, what is the solution of this equation? And they give you some options here. So anytime you see a situation like this and it's multiple choice, what I would do first is I would plug each number in, especially when it's this easy. Plug each number in and see which one works. So you want, if I plug 6 in, I want it to equal this 28. Or 2, I want it to equal the 28. So I'm going to start and be strategic about this. I'm going to start by plugging in this -2 first and then the -6 next. Because if one of those works, then I know it's going to be my answer. This 2 and the 6 are overlaps. So I'm going to be able to eliminate or choose D or C as my answer if one of these works. So let's go ahead and do that. And I'm plugging it in, okay? That's my strategy here. You could go ahead and solve it, but we're gonna plug it in here. So -2, I'm gonna plug in for x. So it's gonna be 2 parentheses, -2 plus 2 squared, and then -4, and we want it to equal 28. Since it equals -4, D is not my answer. Let's check -6. Here's a trick that your calculator does if you don't want to copy down all that again, you can hit second, enter, and it copies down what you just typed in. So then I can just go back in and plug in a 6. Simple as that. That equals 28, which leads me to believe that C is my answer. I am going to double check that 2 works in there as well. So I'm going to hit the second enter button again. Go back in. Now, since you have a negative and a 6, you have to delete one of them if you want to plug in just a 2. So you have to hit this delete button. And then you can put the 2 in over the 6. Enter, and it does equal 28, so C is your answer. If you were solving this the long way, make sure when you go ahead and expand or solve this x plus 2 squared, you have to write it out twice since it's a binomial, so you'd have to do this. X plus 2 minus 4 equals 28. Then you would have to FOIL. Then you'd have to bring everything over to the left-hand side and then factor and then solve from there, and you would have gotten these as your answer. So to save you from all that work, you can just simply plug those in. So the strategy is gonna be called the check strategy. We really essentially here just did our check as if we already had the answer. All right, question 39. What is the largest integer x for which of... Okay, sorry, let me read that again. What is the largest integer, x, for which the value of f of x will be greater than the value of g of x? Okay, remember f of x, y equals, g of x means y equals. I can plug both of these in my calculator and look at the table. So my table values that I'm paying close attention to are gonna be 7, when x is 7, 8, 9, and 10. And I'm comparing f of x to g of x. Now this one's kind of worded a little bit weird. So we'll plug these in and then we'll talk about the wording here. So just pay close attention to which one you're plugging in first. So I'm gonna plug in f of x first. So 5x to the 4th plus 30x squared plus 9. Just triple check that you plug that in right. And then g of x, you have to go down here. It's 3 to the x. So make sure you hit the caret and then the x. And don't just do 3x because that will give you a linear equation. Okay, so those are your 2 equations. We're gonna go right into the table. So second graph. And I'm looking at just those 4 x values, 7, 8, 9, and 10. And now it says, what is the largest integer? So these are the integers they're talking about. 7, 8, 9, and 10. Which one of these 4, which is the largest one of these, where f of x would be greater than g of x. So I'm comparing this number, I want the number in the f of x column, in this column right here, to be bigger than the number in the g of x column. So let's go ahead and record these. I'm gonna start with the largest and go from there. So At 10, it was 5, I should have given myself more room, 53,000, 9 for f of x, and 59,049 for g of x. So is f of x larger than g of x when x is 10? No, this is a smaller number. Okay, let's do 9 now. 9 is 35,244 for f of x and 19,683. Well, that 35,000 number is now bigger than g of x. So 9 would be the largest integer. So it's going to be the same for 8 and 7. F of x is going to be bigger, but they want to know which number out of these 4 is the biggest one where f of x is bigger, and that would be where x is 9. Okay? Question number 40. In the function, f of x equals x minus 2 squared plus 4, the minimum value. So another word for minimum is your vertex. And if you remember from Unit 8, Part 3, this is vertex form of a line. And remember, vertex form is, we always said y equals x minus h squared plus k, where h and k are the numbers in your vertex. So in this case, remember, because the h is negative in the formula, you always have to change the sign of whatever is in that parentheses. So your h, your first value of your vertex is going to be, instead of negative 2, it's positive 2. Your second value, k, stays the same. So 2, 4 is your vertex. If we think about that on a graph, over 2, up 1, 2, 3, 4, your parabola, this is a square, x squared, so it's a parabola and it's positive, so it's opening like this, is going to look like this. So they want to know which one of these values. Is it the 2 or the 4? We can go ahead and cross out negative 4 and negative 2 because those aren't even an option here. Which one of these represents your minimum point or your lowest point? Well, your y value is always your high to low point, right? It's always, we always look on the y-axis when we think about how high or how low something went. So my lowest point on this parabola is going to be where y is equal to 4. All right? And the strategy for this one, remember f of x means y equals. You can plug this into your calculator. You can find the vertex that way. You can even find the minimum. So I'll show you quickly a refresher on how to do that. You can plug in parentheses x minus 2 squared plus 4. In your calculator, you can go to second calc, and you can calculate the minimum. This is, again, going to give you the vertex, so you'd have to still know the difference between the x and the y. You'd go a little left, a little to the right, and enter. So they give you 2, 4. You'd still need to know that the 4 is the actual minimum value. It's the lowest point on the y-axis there, but that would help break it down for you as well. Okay. So the strategy for 39 was y equals and table. This strategy was to calculate the minimum using your calculator. All right. Question 41, which inequality is represented in the graph below? The strategy I'm going to use here is to eliminate wrong answers. Eliminate wrong answers. So I'm going to start by just looking at what they give me here. They're giving me, I'm seeing differences in the inequality. That's a less than or equal to, and that's a greater than. This is shaded above the line. So I can go ahead and get rid of all the less thans. That one and that one. And then let's look at the difference between D and B and D. They have a different slope and a different y-intercept. I think the easiest one to eliminate or to see is the y-intercept. So is the y-intercept at 2 or negative 3? Well, let's see, it's at 1, 2, 3, down 3, so it's at negative 3, meaning it's not this one. It's got to be B. Okay, so for that one, just eliminate wrong answers. Now you can plug that in your calculator. So let's check ourselves by plugging that in. And your calculator shades for you, if you remember from the inequalities unit. To go to where it would be a greater than, you have to tab left. Now my calculator is updated in a newer one. Some of you might just have to hit enter to change. You're looking to change this line to a shade, and I'll show you what it's supposed to look like. So I'll keep my color blue. The line is supposed to be, that's a greater than, that's a less than, okay? When the caret is like in the upper corner, it's greater than, lower corner, less than, and you think about, kind of creates the L for less than. So, oops, there's your greater than. So now this is gonna shade. greater than, and it's going to be 2x minus 3. Go ahead and graph it, and you can match it with this graph. And as you can see, it matches perfectly, so that's my answer. All right, 42 is a repeat. We did that one already. You can do it for extra fun if you'd like. For 43, the equation A equals 1,300 parentheses 1.02 raised to the 7th power is being used to calculate the amount of money in a savings account. What does 1.02 represent in this equation? Okay, now we did not get to this unit. This was part of the exponentials that we're going to get to after spring break. Now we're going to teach you guys this, but it's still something that you and we can at least eliminate wrong answers. So this is an exponential equation. And when you look inside the parentheses, you always want to look to see if the number is bigger than 1 or smaller than 1. So this number is greater than 1. Think of it as like $1.02. So that's greater than $1. So it's going to be a growth and not a decay. So A and C are out. Okay, and then this represents a 2% growth. And the reason being is because you always take what's in the parentheses and you add your percent written as a decimal to it. So if it's a 2% growth, to write that as a decimal, we have to move the decimal over once, twice. So it'd be 0.02. And then you combine that, 1.02, and that's what we found inside the parentheses here. So to kind of undo it, to work backwards, you have to think about, okay, 1 plus what gives me 1.02? Well, it's 0.02. And then you want to write that as a percent. So to change 0.02 back to a percent, I just moved the decimal over twice, and now it's 2%. Okay, that's trickier. If you didn't know how to do that, that's okay, because we didn't teach you that part of the exponentials unit yet, but you will learn that soon. So I would just say eliminate wrong answers here so that you at least had a 50-50 chance. Eliminate wrong answers. And if you weren't sure that if that was a growth or a decay, put that into your y equals and look at your table. Your numbers are going to be growing, so you should have been able to, even if you didn't know anything about exponentials, been able to decide, well, okay, if my numbers started here, oh, whoopsies, that's supposed to be to the, when you put that in your y equals, this is a good lesson. You have to make your exponent x so that it shows you the various values. The 7 was being used to figure out how much was in the savings account after 7 years. But if you put it as x, then you can see that these numbers are getting bigger. They're growing, okay? But again, we'll talk about that after spring break, which we no longer have, but after the week that was supposed to be spring break. Okay, so 44, when factored completely, so that means factored completely means I must factor twice. They're saying this is, and then they give me some options here. Notice what they pull out of all of them, an x, which means I need to pull out a GCF of x first. This is kind of helping to guide me as to what to do first. So remember, when you factor, you always do GCF, dots, or trinomial. You want to pull out a GCF first if they have something in common. These all have an x, so I'm going to go ahead and pull out an x from all of them. And when you divide each term by x, we get x squared minus 13x minus 30 equals 0. Although we're not solving, so we don't have to put equals 0. Okay, and then we have to look at what's inside the parentheses. Okay, so we've pulled out a GCF. Now it's either going to be dots or trinomial. Dots is always two terms. Remember, dots look something like this, x squared minus 64, where you have two terms and a perfect square in both of them, and the minus sign. Trinomial is three terms, 1, 2, 3, which is what we have here, and we call that the AM method, the add multiply. So we call it that because we need to know what multiplies to negative 30 and adds to negative 13. So I'm going to go ahead and find all the multiples to negative 30. When you multiply to a negative number, one has to be positive, the other has to be negative. So like 1 times negative 30 would give me that. 2, positive 2 and negative 15 would give me that. Positive 3, negative 10, and these signs can interchange, so I could make the negative go with the 1 and the positive with the 30. We're just trying to figure out what gives me 13. Okay, so with the options that I have here, let's figure out which one it is. 6 and 5 work as well, but not my option, but so 6 and 5. 5 and 6. Okay. How am I going to add to negative 30? Well, this gives me negative 29, so no. 2 plus negative 15 gives me negative 13, so bingo, there's my answer. A lot of people want to pick 3 and 10, because if they had the same sign, they would add to 13, so just be careful with that. These signs are opposite, so you have to pick 2 and negative 15. And we want to make the 15 negative, because it has to add to negative 13. So I drop my GCF, and I factor my trinomial. I have one positive number, one negative. X squared breaks up into x and x. And then my positive is with my 2, negative is with the 15. And that's how they left all these answers. They just wanted it factored, so my answer is C. And remember, the strategy here is we're going to check to see if that's equivalent to that. If I put that into my y1 and this into my y2, my tables will match. I'm not going to do that because we've done that many times, but that is always your strategy to check to see if you have a match. Y1, Y2, match it up. Just be careful with this one. Let's say they gave you this as one of your options. My second step here, if that was another one of my options in like my A, B, C, or D, and this was another one, if these were two options, they will both show that they're equivalent. So you just have to be careful when they say factored completely. You want to make sure you pick the one that's completely factored, okay? All right, so that's it for the multiple choice today. Let's go on to the short answer. We're going to do question 17, but before we do that, we're going to review 2 ways to graph lines when you're given quadrant 1. Okay, so this works for all lines, but intercepts work best for quadrant 1 graphs. So we're talking about the intercepts work for all lines. You can always use these 2 methods to graph any line, but it works really well, this method right here, when you're given a quadrant 1 only. So remember, let's just review what the heck quadrant 1 means. So quadrant 1 is what I'm looking at here, and that's because usually when I graph, here's your quadrant 1, 2, 3, and 4. Usually I can see 4 quadrants, but in this case they just zoomed into quadrant 1, which is all positive numbers here, okay? That's just quadrant 1. And usually we work with quadrant 1 when we are doing real world problems because we only do positive numbers in real world problems. So let's just quickly review here. So first way we know how to graph a line, which you all are really good at, is y equals mx plus b. So this method can be difficult when the slope isn't nice, and I'm looking at quadrant 1, but that's where you put the equation into y equals mx plus b form, graph with your y-intercept and your slope, or put it in your calculator. To find the intercepts, to find the x-intercept, you plug in 0 for y. So I put that in parentheses there. To find the y-intercept, you plug in 0 for x. So I'll put that in parentheses. And we're going to actually do it with this problem, so leave some space so that we can show our work up here. Okay, so Miranda received a movie gift card for $100 to her local theater. That appears to be the total, so I'm going to make equals 100. And I've already made a mistake, but that's okay. It's easy to fix because down here it says an inequality, so just pay attention to that. Matinee tickets cost $7.50 each, and evening tickets cost $12.50 each. So those are my 2 different types of tickets. If X represents the number of matinee, so X is the number of matinee here, and they said matinee tickets cost $7.50, so $7.50 should go with X. And then they said Y represents the number of evening tickets, and evening tickets was $12.50, so that should be my Y attached to the $12.50. Write an inequality. So I should not have an equal sign, I should have an inequality here, which we'll talk about in a second. That represents all the possible ways Miranda could spend her gift card. So we just want to put our number and attach it to the variable it goes with. So $7.50 X, we're going to add that to our $12.50 because the total, it has to equal 100. Y. Now, it could equal 100, but since I said an equality, it could either be greater than 100 or less than 100, and you have to figure out what makes sense with a gift card. If she has this much money to spend, can she spend greater than or equal to that amount, or less than or equal to that amount? Well, it would be pretty embarrassing if she went and spent greater than the 100 because she wouldn't have enough money. So anytime you have $100 to spend, you want to spend that much or less so that you can cover it all. So we're going to change this equal sign into a less than or equal sign, because if she spent exactly 100, that would be okay too. All right, so there's my inequality. Now they want me to graph it. So I'm going to show you both ways to do this. Y equals mx plus b, I'd have to take this and solve it for y. And when you go ahead and solve, you can change your inequality to an equal sign. Up here, that part doesn't really matter. Just remember when you graph, it's an inequality. So I'm going to do 750 x plus 1250y, and I'm changing it to an equal sign for the purpose of solving for y here. You subtract your 750 over. You get 1250y equals negative 750x plus 100. And then you have to divide everything by 1250. Didn't leave you much room, did I? And you get, I'm going to write it on top here, y equals, so I'm going to do that in my calculator, the negative 750 divided by 1250, and see what I get there. Oop, not typing. Negative 750 divided by 1250 equals 0.6, and I'm going to hit math, enter, since, okay, you can't see anything I'm doing, sorry. So I did negative 750 divided by 1250, got negative 0.6, hit math, and then enter, so I'll show you that again. Math brings you to fraction. You want to just hit enter, because remember your slope is rise over run, and you always want to see it as two numbers. So negative 3/5 x, and then 100 divided by 1250 is 8, plus 8. Okay, so you could graph this equation, or this inequality, using your y-intercept of 8. You'd have to count up 8, and then you'd have to have a slope of down 3 over 5. This one actually is not terrible if you wanted to use the y equals mx plus b method. That's a nice slope. Sometimes the slopes are not nice, and sometimes they're like crazy decimals, and it would be impossible to count the rise over the run. So in that situation, you'd always want to go to the x and y intercept, which I'm going to show you that too. So if you prefer that method, this will work for this particular problem, but not for all. Y-intercepts and x-intercepts will work for every method that has the, most methods, I shouldn't say all, but many of the methods that are your quadrant 1. So for the x-intercept, and it's so quick and easy, you plug in 0 for y. So I'm going to write my equation, 750x plus 1250y equals, and you can make that an equal sign too. Plug in 0 for y, so 750x plus 1250 times 0 equals 100. Well, anything times 0 wipes out there, so it's 750x equals 100 divided by 750, and you have x is equal to 100 divided by 750 is 13.3, repeating. That's my x-intercept, meaning that's where I'm going to plot on my x-axis. I'm going to plot a point at 13.3. For my y-intercept, I can go ahead and plug in 0 for x. So it's 750 times 0 instead of x plus 1250y equals 100. That wipes out. 1250y equals 100, and we just did this math, but 1250, 100 divided by 1250, y equals 8. Okay? So to graph it using your x and y intercepts, you want to just plot at 13.3 on the x-intercept a point, and then at 8 on the y-intercept, you'd plot a point, and you connect them. So it's like connect the dots. So on my y-axis, I'll start with that. I need to go up to 8, so plan your scale accordingly. You do have to scale this, and it has to be the same. These don't have to have the same scale, but if I choose to go up by 1s for the y, I have to continue that for the y. And let's say I choose to go over by 2s for the x, then I have to make sure I'm consistent on my x. But between these two, they can be different. So we'll go up by 1s here because this only has to go by 8. So 1, 2, 3, 4, 5, 6, 7, 8. You probably could have even skipped one and gone up like that to expand the whole thing. So I'm plotting my y at 8. X has to go to 13, so it appears that we have 13 there. So I'll count by ones again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here's where 13 is. 13.3 would be a little bit past it, a third of the way. And I'm plotting that point there. And then you're going to take your straight edge. I'm going to take my charger here. And connect your dots. Now it's an inequality, so you have to ask yourself, is it a dotted or solid line? Because it's a less than or equal to, it's a solid line. If it was just less than, it would be dotted. Okay, and then we have to shade either above or below. Less than means I'm shading below. So all these points within the shaded region, including everything on the line, since it's solid, would be a solution to this system. She could buy 4 matinee and 4 evening tickets and still have less than $100 that she was being charged. So always make sure you label 750x plus 1250y is less than or equal to 100. Make sure these are always labeled, your x and y axes, with the words that we're using. In this case, they labeled it for us. We had to label the scale, which was super important. You can't do this one without labeling your scale. Okay, and then it says, what is the maximum number of matinee tickets Miranda could purchase with her gift card? Explain your answer. Okay, so matinee tickets is represented on my x-axis. They want to know what's the largest number she could purchase. So my x-axis spans from 0 to 13.3. They're saying within this axis here, within these numbers between 0 and 13.3, what's the largest amount of tickets she could buy? So the largest number is 13.3, but you cannot buy 0.3 of a ticket. So I'd have to round that one down because we can't go over. We can't say she could buy 14 tickets. So we have to round it down to 13. So the maximum number of matinee tickets she could buy would be 13 of those and 0 evening tickets and still spend less than 100. So she can buy a max of 13 matinee tickets. And then they want us to explain our answer. I'm going to explain it using math. So I'm going to show that she bought 13 matinee tickets and 0 evening tickets. So 7.5 times 13, there's my X is my matinee, plus 1250 times 0 evening tickets. Is that less than or equal to 100? Let's plug that in our calculator. Is 750 times 13, and we know that times 0 is just going to wipe out, so that's all the math we have to do. $97.50 is less than or equal to 100. So she'd still have enough, but not enough to buy any more, okay? So that's it for this one. Guys, thanks for watching the video again today, and I hope you guys have a great rest of your week.